I'm Daniel Findley with the Institute for Transportation Research and Education at NC State University. Along with my colleagues and the North Carolina section of ITE, or NICSite, we completed a study of large shopping centers in 2007. The following presentation summarizes our research efforts and findings. The Institute of Transportation Engineers produces a standard reference for transportation engineering and site development known as the Trip Generation Handbook. This handbook presents data necessary to estimate trips for a given land use of a specific size. A common question among practitioners is whether or not large shopping center developments, also known as power centers, are accurately represented by data provided in the handbook. Sources of differences between the handbook and new locations could be the wide variety of shopping center types that are currently seen, shopping center sizes, the age of the data in the ITE handbook, and inconsistencies with determining trip estimation. To put this topic in perspective, we can look at the growth in the number of shopping centers in the United States, which have increased from 13,000 in 1972 to almost 108,000 in 2011. The shopping centers in 2011 represent 7.3 billion square feet of space, employ 9.3% of the U.S. workforce, and generate $2.3 trillion in retail sales. For our study, power centers consisted of one or more large national chain stores as the anchor of the development. We only considered sites that had a discount superstore or home improvement superstore as an anchor. The power centers also contained some retail shops that were connected to the anchor and some that were not connected to the anchor. These power centers are a common feature of many suburban areas. The International Council of Shopping Centers defines power centers as developments which contain category-dominant anchor stores and a total size of 250,000 to 600,000 square feet. Site selection for retail development is based on traffic flow, where good access and high volumes are desirable, visibility, where the development would be at eye level to drivers, and size, where there's approximately 1 acre per 10,000 square feet of gross leasable area. Business clustering is used to increase total retail sales within a development. Where there's a broader selection within one location, multiple purchases from separate stores can be made with one trip. A NICSite task force was established to investigate trip generation at power centers. A traffic impact study, or traffic impact analysis, is used to measure the impact of a given development. The most straightforward traffic impact studies are conducted on sites which consist of a single land use type that is well defined and has measurable attributes. As we will see in the following data, power centers have a significant variety of land uses and trip estimation, and it's difficult because of the potential for trip chaining, where a driver enters the development and might visit multiple stores within the development. This action reduces the overall impact of the development and is referred to as internal capture. A survey of state transportation agencies, which included 21 respondents, of those 20 responded that they used ITE rates or equations for power centers, and one state performs site-specific analysis for power center projects. As an example of a power center, the following site in Smithfield, North Carolina is anchored by a home improvement superstore and has some retail businesses, a pharmacy, and several restaurants. For this study, an initial list of 50 sites was collected and then reduced to 10 or 15 based on time and resources. The criteria for selecting sites included the location type, where a mixture of rural, suburban, and urban were desirable. At least one anchor store must be present and must be either a discount superstore or a home improvement superstore, or could also have both. There should be a minimum of 2 out parcels. The number of driveways were important from a data collection perspective, where fewer driveways decrease the level of effort required to collect the data. The length of time in operation was important to make sure that the site had matured enough so that traffic had established itself. The type of roadway was also important, whether it was a commuter or residential area. The adjacent street ADT, or traffic volume. The types of uses were important, and this study included no residential or exclusively office-related businesses. The number of junior anchor stores were considered. The site interconnectivity, so how well drivers could travel between stores within a development, and also the proximity to an interchange. This chart displays the data from our study that describes each site and the associated traffic volumes. The bars are measured on the left vertical axis and are stratified by anchor, outparcel, and inline retail square footage. The dots denote the traffic counts on the right axis and vehicles per hour. Circles represent the traffic volume in the Saturday peak hour, the triangles are afternoon peak hour volumes, and the squares are the morning peak hour counts. The 10 locations were all in North Carolina and included sites in Smithfield, Greensboro, Clayton, Asheboro, Whiteville, Charlotte, and Siler City. The NIC Site Task Force, which was comprised of consultants, researchers, and Department of Transportation employees, developed a consensus agreement that 3 scenarios are common for evaluating large shopping centers. The first option is to analyze all square footage in the development as the shopping center land use type from the ITE handbook. The second option was to analyze the anchor store and inline retail as the shopping center land use type and the out parcels as their individual land use type. The third option was to analyze the anchor store as its individual land use type, the inline retail stores as the shopping center land use type, and the out parcel stores as their individual land use type. Among the 10 locations, the average morning peak hour experienced 680 trips per hour, the average afternoon peak had 1,450 trips per hour, the peak hour on Saturday had 1,880 trips per hour, and the average daily total was 18,760 trips per day. For each scenario, the asterisks denote whether there is a statistically significant difference from the actual counts. A scenario that doesn't have a statistically significant difference means the scenario performed well for estimating the average trips. Among the 3 scenarios, only one scenario at each peak hour time period showed no statistically significant difference from the actual counts. Scenario 2 during the AM peak, and Scenario 1 at the PM peak and Saturday peak. No significant difference among the scenarios and the daily total existed, although Scenario 1 produced the smallest average difference. This graph visually represents the data we saw in the last table by showing the average percent difference from the actual counts for each time period. Again, Scenario 2 in the AM peak had no statistical difference, and Scenario 1 in the PM peak and Saturday peak. All the scenarios had no statistical difference in the daily total. The performance of Scenario 1 is likely attributable to the notion that the estimate from the ITE land use code does not double count vehicles that visit multiple stores within the development. However, the other scenarios would need to have an internal capture factor applied for the final estimate. Therefore, the overestimations in each time period for Scenarios 2 and 3 are likely attributable to the effect of internal capture. The recommendations are based on the results of the data analysis and the finding of no statistical difference for one scenario at each of the hourly time periods. Therefore, Scenario 1, using the shopping center land use code 820 for all square footage, is recommended for the PM and Saturday peak hours, as well as the daily total. Scenario 2, which analyzes the anchor store and inline retail as the shopping center code, and out parcel stores as their individual land use code, is recommended for the AM peak. Thank you for your interest in this research effort. Full documentation of the study was published in ITE's Journal of Transportation in Volume 4, Issue 1 in November 2012.